Hello, my dear Pauls. You are with Ekadisa in the channel Classes with iLearn. Today's topic is problems based on equation in stoichiometry. Now, we shall classify the problems into three categories. First, a weight-weight relationship, weight-to-volume relationship, and a volume-volume relationship. So to begin with, let us have some problems related to the weight-weight relationship. The first problem, calculate the weight of 50% sulfuric acid required to decompose 60 grams of chalk. You know, chalk is calcium carbonate. It is given Ca40. You know, it is the RAM, relative atomic mass of calcium 40, carbon 12, oxygen 16, and sulfur is 32. It is given. Now, to work it out, first let us find out the balanced chemical reaction. The reaction CaCO3 plus H2SO4 turns into CaSO4 that will be deposited plus CO2, carbon dioxide gas will be evolved, and H2O, water. Now calcium carbonate, you know, if you sum up the calcium carbon, the masses of oxygen 3 atoms, it happens to be 100 grams. H2SO4 is 2 plus 32 plus 64, 98 grams. Now from this balanced equation, you know, it is clear that 100 gram of calcium carbonate react with 98 grams of sulfuric acid. Therefore, the amount of sulfuric acid required for 60 gram of chalk, that is calcium carbonate, is equal to 98 into 60 upon 100, very easy, it is 58.8 gram. Now, as 50 grams of sulfuric acid are contained in 100 grams of 50% acid, it is given 50% acid you have to take. So, in 100 gram of 50% acid, we will be getting 50 grams of sulfuric acid. Therefore, the weight of 50% of acid required is equal to 100 into 58.8 upon 50, that equals to 117.6 gram. Now, we will take one example when the reactions are in successions. Like you know, 1 liter of an acidified solution of potassium permanganate containing 15.8 gram of potassium permanganate is decolorized by passing sufficient amount of SO2. If means sulfur dioxide, if the SO2 is produced by roasting iron pyrites having formula FeST, you know, what will be the amount of pyrites required to produce the necessary amount of sulfur dioxide? This question was set in the IIT admission test in the year of 1974. Given potassium 39, manganese 55, S means sulfur 32, iron 56, and oxygen 16, relative atomic masses. Now let us do it. So first of all, you have to write the balanced equations that is occurring there. It is 2KMnO4 plus 5SO2 plus 2H2O yielding K2SO4, 2MnSO4, it is decolorized. It is purple in color, it is colorless, plus 2H2SO4. Now 4 FeS2 pyrites plus 11 O2 roasting we are doing, that is 2 Fe2O3 plus 8 SO2. This is the sulfur dioxide that is produced. Now see, the molecular weight of potassium permanganate KMnO4 is equal to, I have added 150 grams, 58 grams. FeS2 iron pyrite is 120 grams, I have shown it. Now according to the equation A, 2 moles of KMnO4 that requires 5 moles of SO2, and from the equation B, you know, 4 moles of FeS2 pyrites produces 8 moles of sulfur dioxide. Now from these reactions A and B, we see that 2 moles of KMnO4 that will be equivalent to 5 moles of sulfur dioxide and equivalent to 4 by 8 into 5 means 5 by 2 moles of FeS2. Therefore, you know, moles of potassium permanganate taken, it was given 15.8 grams by the molecular weight 158, that is 0.1. Hence, the moles of FeS2 required is equal to 5 by 2 into 0.1 upon 2, that equals to 0.125. Therefore, weight of FeS2 iron pyrites required is equal to 0.125 into 120, that amounts to 15.00 gram. Now a sum from mixtures. A mixture of FeO and Fe3O4, okay, it's magnetic. When heated in air to a constant weight, gains 5% in its weight. Find the composition of the initial mixture. Given Fe is equal to 55.8, oxygen 16. This was a question set in the IIT admission test in 1978. Now, the balanced reactions are first 2 FeO plus half O2 Fe2O3. You just add it, it is 143.6 gram, and here it is 159.6 gram. And the second reaction is 2 Fe3O4 plus half O2 turns into 3 Fe2O3. Here it is 462.8 gram, you just add it, and it is 478.8 gram. Now let the weight of FeO in the mixture be x gram, and that of the Fe3O4 would be 100 minus x gram. Now if the total mixture taken is 100 gram, okay. Now weight of Fe2O3 produced from x gram of FeO according to the equation number 1 is equal to x into 159.6 upon 143.6 gram. And also the weight of Fe2O3 produced from 100 minus x, I have taken 100 gram altogether. So 100 minus x gram of Fe3O4 according to your equation number 2. That equals to 100 minus x into 478.8 upon 462.8 gram. Therefore, the total weight of Fe2O3 produced would be this plus this one plus this one, and that equals to 105. That is given 5% gain in its weight. That is 100 gram was there, and now it is 105 grams. Now just you solve it for x, and you get x is equal to 20.78 gram. Okay, so hence the percentage of FeO is 20.78, and that of the Fe3O4 is 79.22. That is the answer. Now let us work out the next question. Igniting MnO2 manganese dioxide in air converts it quantitatively to Mn3O4, trimanganese tetroxide. A sample of pyrolusite is of the following composition: MnO2 80%, SiO2 silica, and other inert constituents is equal to 15%, rest being water. The sample is ignited to constant weight. What is the percentage of manganese in the ignited sample? This is the question given. Mn means the RAM 55 and O16, oxygen 16. This was a question set in the IIT admission test in 1978. Okay, let us work it out. You know, the reaction is 3MnO2 turns into Mn3O4 plus oxygen liberates. So if you add it up, 261 gram, and this is 229 gram. So let the sample taken be 100 gram. Mn3O4 produced according to the equation, this equation, due to 80 gram of Mn3 present in the sample, that equals to 18 to 229 by 261, happens to be 70.19 gram. The amount of unaffected inert sample, that equals to 15 gram. 15% is given, you have taken some 100 gram, so 15 gram is obvious. Therefore, the total residue is equal to 70.19 plus this 15 adds up to 85.19 gram. Therefore, percentage of Mn3O4 in the ignited sample is equal to 70.19 by 85.19 into 100. Therefore, the percentage of manganese in the ignited sample is equal to this one, that into 165 by 229. And if you calculate it, it becomes 50.39, and that's the answer. So let us work out the next question. The oxides of sodium and potassium contained in a 0.5 gram sample of feldspar were converted to the respective chlorides. The weight of the chlorides thus obtained was 0.1180 gram. Subsequent treatment of the chlorides with silver nitrate gave 0.2451 gram of silver chloride. What is the percentage of Na2O and K2O in the sample? So this is a question given: sodium 23, potassium 39, silver 108, nitrogen 14, chlorine 35.5. So this was a question set in the IIT admission test of 1979. Okay, let us do it. The subsequent reactions will be Na2O plus 2HCl converts to 2NaCl plus H2O. This is the molecular weight, 62 gram, and this is 117.0 gram. Equation number 1. K2O plus 2HCl, this is 94 gram, 2KCl 149.0 gram plus H2O. Equation number 2. Next is NaCl plus AgNO3. We are reacting, So the silver chloride will be precipitated, white precipitate, 143.5 gram plus NaNO3, that goes into solution. So this is question number 3. And KCl plus AgNO3, that precipitates on the silver chloride, once again 143.5 gram plus KNO3, it is soluble in water, that goes into solution. Question number 4. Now let the weight of the sodium chloride in the mixture of the chlorides be x gram. We have taken x gram. Let the weight of the NaCl in the mixture of the chlorides be x gram. Therefore, the weight of KCl in the mixture is equal to the rest, 0.1180 minus x gram. Okay. Therefore, the weight of the AgCl that would be obtained from x gram of sodium chloride, very simple equation, that is 143.5 into x upon 58.5 gram. Again, the weight of the silver chloride that would be obtained from 0.1180 minus x gram of KCl, that equals to 143.5 into 0.1180 minus x whole into upon 74.5 gram. Total weight of silver chloride obtained from the chlorides, thus the previous one and this one, gram, and that happens to be 0.2451 gram. It is given in the question. So solving the both sides, you get x is equal to 0.0342 gram. Therefore, the weight of KCl, that will be 0.1180 minus 0.0342, that equals to 0.0838 gram. Now, according to the equation 1, the weight of sodium oxide, disodium monoxide, Na2O, corresponding to 0.0342 gram of sodium chloride is equal to this thing, 0.0342 upon 117, and naturally the percentage will be 0.0342 into 62 by 117 into 100 by 0.5, and that happens to be 3.62. So this is the percentage of Na2O in the feldspar. Again, the weight of K2O corresponding to 0.0838 gram of KCl, that equals to this thing, 0.0838 into 94 upon 149 gram. And the percentage of potassium oxide, K2O, in the feldspar will be 0.0838 into 94 by 149, that into 100 by 0.5, and that happens to be 10.57 gram. So that was what wanted in the question, and this is where we end our this session. Now, my dear ones, if you are liking the content of the videos of classes which I learn, I, Ekidisa, will request your pleasure to subscribe, share and like my channel.